In this exercise, number 10 on page 226, we're going to take all the stuff that we've been looking at with binomials and put them together into answering a question regarding interpreting unusual events. So here we're going to be looking at Mendel's theory about p's and p color. Now, what we're going to be looking at here is the beginnings of hypothesis testing logic of if-then. So, although we're still a ways away from t-tests, chi-squares, and other things like that, this is an example of applying the basic logic and reasoning that underlies hypothesis testing and looking at how, with what we know right now, we can actually make some assessments in support of or in dismissing particular. Here's how this works. If a hypothesis testing if-then logic, if a theory is correct, then we would expect to see blank number of yellow pods. This is the if-then statement put forward. This is the basic hypothesis. So we then assess the accuracy of this theory by whether or not the prediction is met. So this is what we're looking at, basic hypothesis testing. If-then. If the theory is correct, about 25% from one sample of peas would be yellow, then we would expect to see this number of yellow peas. Now keep in mind we can't look at the exact number because of course there's going to be a certain amount of variation around that. That's the standard deviation, remember? So since we have a standard deviation, that means we can't just use straight up the mean. So that's why we're going to calculate, use our mean and our standard deviation to make some calculations to answer this question. So let's take a look at this together. Alright, so we need to get the mean and the standard deviation first. So to get those, as we know from our formulas, we need to get our n and our p. So pause the video here for a moment and write down what the n and the p are. And also, if you can, calculate your q. Pause the video and do that, and then when you've finished and you got your answers, turn the video back on and let's check them together. Okay, you should have got an n of 580. That's the number of p's that we're looking at. And p, notice here I've cued it as yellow. That's what we're talking about here. This is another place where paying attention to getting, you're leaving yourself a trail of what kind of problems you're trying to solve. What each of these represents is really important. So p of yellow here is 0.25. And then, of course, my q, my probability of getting a green, is 1 minus 0.25, which is 0.75. So now take a moment here, again, pause the video and plug these into the formulas for calculating both your mean and your standard deviation for this binomial. And then when you have that done, turn the video back on and we'll check it together. Alright, so you'll be using these formulas here. So your mu n times p and my standard deviation is the square root of n times p times q. And so we plug our numbers into that. Here's what we get. So our mean is going to be 145 and our standard deviation is going to be 10.4. So now we have those pieces of information. We need to move on to comparing this. This is our predicted amount. Remember, if Mendel's theory is correct, then the mean and the standard deviation here are going to let us set the parameters for what is a usual expectation of having yellow peas. And we're going to apply that to the actual results of the experiment, which was 152 yellow peas. So if we're going to do this, what approach do we need to use to answer this question of whether or not 152 yellow peas is an unusually high amount? We're going to use our range rule of thumb here. So we're going to calculate our minimum and our maximum based on the mean and the standard deviation for this particular problem. So pause the video here, get your formulas for calculating for your min and your maximum, and then plug the values in. And when you've got your answers, turn the video back on and we'll check it together. Alright, you'll be using your formula of your mean minus 2 times the standard deviation for your minimum, and your maximum will be determined by mean plus 2 times the standard deviation. So you'll be getting 124.2 as your usual minimum amount and 165.8 as your usual maximum amount. Alright, so now that we have this information, here we've got our minimum, we've got our maximum, and we have our actual amount of 152 p's. So how do we put these pieces together to answer the question of, is this an unusually high amount of yellow peas? And then the follow-up question of, what does it suggest about Mendel's theory? We're going to put them together just like this. So here you can see you're putting the order numbers from lowest to highest. So if 124.2 is less than 152, which is less than 165.8. So is 152 an unusually high amount of yellow peas based on this data? No, because it falls within the min-max range. Notice it's in the middle. And since it falls within the min-max range, then do these results support or reject Mendel's theorized percentage estimates? And what does that mean about the accuracy or the inaccuracy of his theory? Well, these would support it, as it fell within the range of the usual values, which means that it would indicate that his theory was accurate. Okay, this is our last problem for the binomial. Working through from the beginning to end. So we'll be moving from here to exam 2. Good luck on that. And then when you're finished with exam 2, we'll be getting back together again after we all are back from spring break. So have a good spring break. Good luck on exam 2. And I'll see you all when you come back.